Hello, I'm Dan from Peking University. It's my honor to share with you one of my work about social contagion effect of race and ambiguity.
Studies have found that humans' risk preference can be altered by observing others' decisions. This is called the social contagion effect of risk preference. It is also true in many real-life scenarios, especially in the stock market, where people always follow others to buy and sell their stocks. However, considering that people have a natural tendency to avoid risk, it remains unknown whether such social contagion effects are symmetric between observing risk-seeking and risk-averse individuals. Besides, there are two different types of uncertainty, where risk is uncertainty with known probability, ambiguity is uncertainty without the probability, and it is more common in real life. So it is worth exploring whether the social contagion effects also exist in the context of ambiguity, and what's the difference between risk contagion and ambiguity contagion effect. Furthermore, according to the framing effect, people tend to avoid risk when potential gain is emphasized, and seek risk when potential loss is stressed, even though the outcome is actually the same. This is also true for ambiguity. So we also investigated whether the contagion effects are modulated by the decision frame. Here, we designed two experiments to address these three questions. Our first experiment studied the risk contagion effect. In each trial, participants would first receive an initial amount of money and then decide between a gamble option and a short option presented in either gain frame or loss frame. Throughout the experiments, participants also needed to observe and predict decisions made by two other agents. We call it observee here. One is risk-seeking, who love to choose a lot of gambles. Another is risk-averse, who seldom choose gambles. The order of two observees was counterbalanced across participants. We estimate people's risk preference based on an exponential utility function, where alpha represents risk preference. Alpha higher than 1 means risk-seeking, alpha lower than 1 means risk-averse. We wanted to say how people change their risk preferences when observing different observees and in both decision frames. Here is an example of one participant's risk preference changing over time. After observing a risk-seeking observee in session 2, he shifted his risk preference and became a little more adventurous. Later, after observing a risk-averse observee in session 4, he shifted his risk preference again towards risk-averse, and the amount of change in one's risk preference delta is defined as the degree of risk contagion. The risk contagion effect was significantly above zero in all conditions. Specifically, in the gain frame, risk contagion has no difference between observing risk-seeking and risk-averse observees. But in the loss frame, the contagion effect was substantially stronger after observing a risk-averse observee than a risk-seeking one, which indicated an asymmetric effect. However, because people in the gain frame were initially closer to risk-averse observee, leaving them less room to change, the risk distance might have limited the risk contagion effect. Therefore, we could not rule out the possibility that stronger risk-averse contagion effect also existed in the gain frame, only in an implicit way. To test this hypothesis, we calculated the risk-contagion ratio, which is contagion divided by distance. It reflected the change in risk preference relative to the space left for change. By doing so, we find that no matter in gain frame or loss frame, observing risk-averse observee always generates larger effect than observing risk-seeking one. Furthermore, our regression results show that when people observe a risk-averse agent, the greater the distance, more likely they are going to change. But this pattern did not exist when observing a risk-seeking observee. In summary, all the results suggested a symmetric contagion effect. People are more likely to learn to become risk-averse. In our second experiment, we want to find out whether contagion effect also occurred during ambiguity decision-making. We introduced ambiguous gamble into the task. An ambiguous gamble's probability was made unknown by covering part of it with a glue uploader. The tasks still include two decision frames, and the overall schedule was similar to the first experiment. Only this time, participants observed two different observees, one extremely ambiguity-seeking but slightly risk-averse, and another extremely ambiguity-averse but slightly risk-seeking. People's risk and ambiguity preference are separable based on a maximum utility function. Beta represents ambiguity preference. Beta higher than 0 means ambiguity-seeking, beta lower than 0 means ambiguity-averse, and alpha still represents risk preference. We find that the ambiguity contagion effect did exist. The figure again showed an example participant who shifted his ambiguity preference towards others after observations. We also plotted his risk preference across 4 sessions, but it changed little, suggesting that ambiguity contagion is separate from risk contagion. At the group level, the ambiguity contagion effects were symmetric between observing ambiguity-seeking and ambiguity-averse observees under both decision frames. Besides, we also replicated a stronger risk-averse contagion effect in the loss frame as in experiment 1 with smaller effect size. Our regression results showed that ambiguity contagion was equally influenced by distance to ambiguity-averse and ambiguity-seeking observees, indicating symmetric effect, and we again replicated results from experiment 1 about asymmetric effect of risk contagion. Finally, we compared the contagion ratio across two experiments and again solidified our conclusions that the risk contagion is asymmetric and ambiguity contagion is symmetric. It may suggest our natural tendency to explore social information equally in an ambiguous context, but particularly exploit conservative social information in a risky situation. This is all, and I'd like to thank my two kind mentors, Dr. Lusha Zhu and Dr. Jian Li, and the graduate student Qingtian Mi. They give me a lot of support, and thanks for your listening.